So now let's see the next question. Question number 19, and this is my favorite question. And one very important point I will tell you to note down in your notes. Suppose you have a function from set x to set y. This is a function. Which of the following are possible? The question is asking which of the following are possible. Is it possible? You have a function. Is it possible it can be injective but not surjective? Is it possible? Of course, very much. You can say very much. Of course, possible. The question is asking possible, of course. Can you give me a function? Can you give me a function which is injective but not surjective? Very easily you can give. For the first option, you can just give me this function. A, B, C. Injective but not surjective. So I can give you this function. This is injective but not surjective. You can easily notice that this is 1, 1. And you can see that this is not onto. So I can give you this function. Agree? Okay. I can give you this function also. F is surjective but not injective. I can give you, like I can say ABC. I can say 1, 2. I can give you this function. You can see that this function is onto, but this function is not 1, 1. So easily I can give you this function also. Okay. Try to give me this function. Can you give me try? Can you give me this function? Anyone? Anyone? Can you give me this function? Like where cardinality must be same. X, y should have same cardinality. F should be injective, but F should not be surjective. Can anyone give me such function? Is it possible to give me such function? Is it possible to create this type of function? Please tell me. Is it possible? Can you do? Can you take your copy pen and do? Try this. Try to create. Take your copy pen. Try to create. So, okay, let me try. Shall I try? Okay, let me try. Their cardinality must be same. F should be injective, but F should not be surjective. Okay, let me try. I can do that very easily. See, question number 3. That is also possible. This is also possible. Okay, and let me give you, for example, I can give you a function from n to n, from natural numbers to natural numbers. You know, from natural numbers to natural numbers. So I can give you this function where F will be injective, but it will not be surjective. Okay, F will be injective and F will not be surjective. For example, just consider this function x equal, just consider this function. Consider this function. Tell me, what about this function? Look at this function. Just look at this function. Fx equal to x plus 1. Just look at this function. Is this surjective? Is this function surjective? From n to n, from natural numbers to natural numbers, 1, 2, 3, 4, 5, and so on. 1, 2, 3, 4, 5, and so on. So tell me, you can say the image of 1 is 2, the image of 2 is 3, the image of 3 is 4, the image of 4 is 5, the image of 5 is 6. Is this? So you can see this is not, clearly this function is not onto. Agree? Clearly this function is not onto. Why this is not onto? Why this is not onto? Because this one is not covered. This one is not covered. And clearly this function is 1, 1. Clearly this function is 1, 1. Is this clear? Please tell me. Will you keep this in mind? But let me tell you something very interesting. Very interesting, let me tell you. I am taking the help of infinite sets. The world of infinity can do weird things. The world of infinity that can do weird things. So I am taking the help of world of infinity. But if I ask you, can you give me injective but not surjective? Means this type of function, if I ask you, see, in the same question, if I ask you, give me finite set. See, please understand, like this question, if I ask you, give me finite set. X, y are finite, their cardinality is same, and now you give me injective but not surjective. Now can you give me, please tell me. Understand? I am asking this question number F, I am asking. This, sorry, question number E. This question number E I am asking. Please take your copy pen. Please do that. Take your copy pen. From x to y, f is a function. This f is a function. Okay. Cardinality is same. Cardinality of x is equal to cardinality of y. They are finite. This is important. They are finite. X comma y are finite. Okay, they are finite. Now you give me is, remember f x comma y are finite. Now you are in the world of finiteness. So now you tell me, can f be injective but not surjective? Can f be 1 1 but not onto? Can f be 1 1 but not onto? If you see, if you try, let's try to do it. Okay, you cannot do it because if you take total, for example, if you take total, like let me take, if you take, like, for example, 5 elements, you take a1 a2 a1 a2 a3 a4, take 4 elements. Here also take 4 elements, b1 b2 b3 b4, take 4 elements. Now you do, now just try to do. Here you can notice the cardinality of x is equal to cardinality of y. You can also notice x comma y are finite. Okay, now you try, just try your best. Can you create, means we want to create 1 1, but we don't want to create onto. I want to create 1 1. So a1 mapping to b1. Okay, let's assume a1 is mapping to b1. Can a2 map to b1? Can a2 map to b1? Is it possible? No, I want to create f which is 1 1. I want to create this 1 1, but I don't want to create onto. I want to create 1 1. I don't want to create onto. So please understand, I do not want to create onto. This type of function I want. So because I want 1 1, so can I do this? I cannot do this because I want 1 1. 1 1 means different elements should have different images. So I cannot do this. Okay, so let me do this. Now tell me, can I do this? I cannot do this because I want 1 1 function. So different elements should have different image. Can I do this? No, because I want 1 1 function. So different elements should have different images. Let me do this. Now similarly, you can notice, can I do this? No. Can I do this? No. Can I do this? No. Finally, that's it. Whatever I do, whatever efforts I put, I can put whatever efforts I put, but this type of function is not possible, right? Agree? In this situation, in this situation, in this situation, in this situation, this type of function is not possible. F equal to 1 1 but not onto. F equal to 1 1 but not onto. This is never possible. Understood? Please tell me. Is this point understood? That this function is never possible. This type of function is never possible. Anyone here has any doubt? See, this is simple point, because if you take, you can take any finite set, it does not matter. A4 and so on, AN. You want same cardinality. You want same cardinality. BN. Okay, so you want the same cardinality you want. So now you tell me. Tell me. So here you can notice, again you have same cardinality. This is set X, this is set Y. They have same cardinality and both are finite. Both are finite. Here you can notice, because you have n elements here and you have n elements here. They have same cardinality and this situation. Now in this situation, you can try if you want, but this type of function you cannot create. In this type of situation, f equal to 1 1 but not onto. But not onto. This is not possible. The reason, let me give you the reason. Tell me, if two people cannot map to same element, then for n people, how many people I need? Simple, right? If it's like, if two, for example, if two people cannot marry the same person, Okay, let's assume there are total some, I can say 10 male are there. Let's assume. Okay, let's assume total 10 males are there. If two males cannot marry the same woman, then at least how many girls you need? At least how many women you need so that they can marry? So at least 10, right? At least 10. Okay, so this is the same thing. What I'm saying, that if you have total, let's assume total 10 items you have, total 10 people you have, or maybe 10 elements you have. Two elements cannot map to the same element. So let's assume total 10 elements you have. These are the 10 elements. Two elements cannot map to same element. Then to cover, to map all of them, at least how many elements you need? At least 10 elements you need, right? So that you can map them. Because two elements cannot go to same. Two elements cannot go to same. This cannot happen. So if this cannot happen, then for 10 people, you need at least 10 people. So here you can notice. Now you tell me, for 10 people, you need at least 10 people, because two people cannot go to the same element. These two people, they cannot go to the same element. So it means for 10 people, I need 10 people. Now, if I don't have extra people, then it simply means we have covered it. Agree? If these have same cardinality, if I don't have extra people, then it simply means I covered it. I covered the entire set. Please tell me, is this point clear? Let me know. So simple point that if your cardinality is same, set X, set Y, they have same cardinality, and these are finite set. In this situation, if you create one function, that means different elements cannot go to same element. This cannot happen. So for these n elements, you need n elements, so that you can do this. For n elements, you need n elements. Now, if you don't have extra people in this set Y, then what will happen? If you don't have more people, because they have same cardinality X and Y. So if you don't have extra people in Y, then it means Y has been covered. Can I say Y has been covered? Entire Y has been covered. So means your function has become onto. Means your function has become onto. So simple point. Is this clear to everyone? Let me know. So you tell me one thing. A very important note I am writing here. And tell me, did you understand this note? Function f from x to y, if cardinality same, and they are finite. This finiteness is very important, right? Okay. If they are cardinality same and they are finite, then tell me, then if you create 1 then automatically it will be bijective. Then if f is 1 then f is bijective. Then if f11, then automatically it will be onto. If f11, then f will automatically be onto. Clear? If f11, then automatically f will be onto. Clear? Let me know. Please tell me. In this situation, if f11, then automatically f will be onto. Now tell me the other situation. Tell me this other situation, that this question number f. Your function from set x to set y, the cardinality of x is same as cardinality of y, and x comma y are finite. They are finite. Now you tell me, x comma y, they are finite and you have same cardinality. Now, can you create this type of function that f is onto but not 1 Can you create? Try this. At least try this. Please try to create f equal to onto but not 1. Can you create this? Take your copy pen and try to do this. Function onto but not 1. You will see this is also not possible. You will see this is also not possible. For example, again, very similar example you can take. Like if you have 4 elements, A, B, C, D, you have 4 elements, 1, 2, 3, 4. This is set X, this is set Y, this is the function. Both are finite. Both X, Y are finite. And their cardinality is also same. Now you can easily notice, if I create onto, I want a function. This I want to be onto. I want this to be onto. So let's create a onto function. So let me cover this one. Let me cover this one. See, I want onto function. So can I do this? I want onto function. I want onto function. So can I do this? Can I do this? I can do this, but there will be a problem. See, I want onto function. I want onto function. So can I do this? I can do this, but there will be a problem. What will be the problem? Now you cannot create the onto function. Now you cannot create the onto function. See, now you cannot create the onto function because now you have less number of elements here, more number of elements here. Less number of elements here, more number of elements here. Now you cannot create onto function. So this is what I'm saying. If you do this, then you cannot create onto function because less number of elements here, more number of elements here. So that's the reason you have to do this. Now, if you do this, see, if you do this, now what will happen? Now again, you cannot create onto function because less number of elements here, more number of elements here. So again, you cannot create onto function. So finally, you can notice that this is the only way. This is the only way. So if you create onto, then automatically it will be 1, 1. Right? Yes or no? In this situation, when you have this situation, in this situation, if f is onto, then automatically f will be 1, 1. Understood? I hope you understood this. Please tell me. So this is the final conclusion I want to give. So is this possible? Can f in this situation, when they are finite, f, though both the set are finite, x, y are finite, they have same cardinality, then is this possible? Not possible. Similarly, this question, that is this possible that you have onto but not 1, 1? You have onto but not 1, 1. This is also not possible. This is also not possible. So finally, the conclusion is what? Remember, finiteness is very important. Please understand, finiteness is very important because I can, from n to n, I can do this. See, finiteness is very important. Of course, here this set and this set have same cardinality. Like this is your set x, this is your set y. Of course, they have same cardinality. Agree? Agree, they have same cardinality. Right? They have same cardinality. But you can notice, now I can create whatever function I want to do. Now I can create whatever function I want to create. For example, I can create this type of function. Like I can create this type of function I can create. Means I can create this fx equal to x plus 1. And you can notice that this function will be 1, 1, but this function will not be onto. So when you have infinite set, then you can create some weird things. Right? Agree? Do you agree with me? When you have infinite set, then you can do some weird kind of things. But the point is, if your set are finite, but this is the point. So please take this note and write in your notes also. And this is very important. Okay. So, because in the gate exam, they can ask you some tricky question. So please understand that you have function f from set x to set y. And let's assume that cardinality of x is equal to cardinality of y. And let's assume x, y finite. If this is the situation, then what will happen? In this situation, this will happen. This, see, in this situation, if f11, then automatically what it will be? If f11, then automatically it will be onto, right? Automatically it will become onto. And if f onto, then automatically it will become what? Then automatically it will become 1, 1. Okay. If f onto, then automatically it will become 1, 1. If f11, then automatically it will become onto. So can I say that in this situation, f is 1, 1 if and only if. In this situation, I can say f is 1, 1 if and only if f is onto. if and only if f is onto. I can also say, can I say f is 1 1 if and only if f is bijective? Right? I can also say that f is 1 1 if and only if f is bijective. I can also say f is onto if and only if f is bijective. All these points, are they clear? Let me know. So a good question, an interesting question, right? Tell me, understood all these points? Did you understand? So this finiteness is also very important, and same cardinality. In these situations, 1 1 and onto, they basically, they come together, they go together. Okay, they come together, they go together. In this situation, you can also say that f is not 1 1 if and only if f is not 1 1, then f is not onto also. In this situation, f is not 1 1 if and only if f is not onto. That will also happen, because they will come together, they will go together. In this situation, they will come together, they will go together. Clear? So this is the question that you have. A very interesting question. Now, are you finding why I was saying that this is interesting question? One of my favorite question. So finally, you can see this is possible. And what about, so what about E? Is this possible? Is this E? This is possible. This is not possible. F is not possible. Finiteness equal cardinality. F is not possible. E is not possible. Did I give you example for C? C possible. C possible. Did I give you example for C? Yes, I have already given you. So C is possible. What about D? Now you tell me D. Is D possible? Surjective but not injective. Can you give me D? Give me a function D. For option D, you give me a function. I want a function for option D. For option D, I need a function which is surjective but not injective. I want surjective but not injective. Think about it. I want to cover all the elements. I want surjective but not injective. Anyone? See. Forcefully. What you do this. Okay. Here you do this. Here you do this. And the remaining what you do this type of thing. So piecewise function you do. Okay, you do this. Are you getting my point? What I'm saying? I'm saying consider this function. I'm giving you a piecewise function. I'm giving you this type of function. I'm saying that fx is equal to 1 if x is equal to 1 or 2. Is this clear? I'm saying fx is equal to 1 if x is equal to 1 or 2. Else fx is x minus 1. Otherwise fx is equal to x minus 1. So tell me, is this function on your screen? This function is not 1 1, but this function is on 2. Agree? On your screen, this function is not 1 1, but this function is on 2. Is this point clear? This function, look at this function. This is not 1 1, but this function is on 2. In this function is on 2. So very simple. That if you have finite set and they have same cardinality, then 1 1 if and only if on 2. 1 1 comma on 2, they will come together, they will go together. In this situation, when both set are finite and they have same cardinality. Okay, so this is quite interesting. This thing is quite interesting. Now in your life, okay, please understand, because I can create many tricky questions. A lot of tricky questions I can create. Why? See, this type of questions can be created. This is a note that I want to give you. In any question, if you see these things, in any question of functions, if you see these things, in any function question, this is what I want to tell you. Actually, basically, I'm telling you that you should take care. In any function question, if these things you see, if you have function from x to x, agree? If you have this type of situation from x to x and x finite, if you see this combo, then what you should care? Now, immediately, what should come to your mind? Tell me. If you see this combo from x to x, x is finite. Means they have same cardinality and x is finite. They have same cardinality and x is finite. From x to x, they have same cardinality and this is finite. Immediately, what should come to your mind? Immediately, can I say f is bijective? In this situation, can I say f is bijective? Then can I say f is bijective? Then can I say f is bijective? Of course not. Of course not. Okay, don't say bijective. Of course not. Okay, in this situation, don't say. May or may not. May or may not. Okay, for example, take this function from x to x. Take this function 1 to 3, 1 to 3, x to x. Okay, so you can just take this function. Look at this function. This is from x to x is finite. Still, this is not bijective. So don't say that. But what you can say? May or may not. But what you can say? So when you see this situation that x to x and x is finite, please, whenever you see this combination, immediately you should remember that immediately you should remember that if it is given that f is 1 1, then immediately what you should also write in your, when you are solving this question and this is given that f is 1 1, then immediately when you are solving this question, you should also write that f is on 2. Is this clear? Then immediately you should also write that f is on 2. Basically, f is bijection. This is what I'm telling you. Whenever you see this combination, this combo, this is a deadly combo. This is a deadly combo. I can create 15 questions, maybe 20 questions I can create, in which this deadly combo, you can make mistake if this thing does not come to your mind. Basically, what I will do, see, what I will do. I will give you a function from x to x. I will say that it is finite. And I will only give you this information. I will only give you this information. I will not give you this information. Then when you are solving, then you will have this information in your mind. But you will not be having this information in your mind. So it is possible you can make some mistake. Agree? Agree with me? Agree with me? So what I will do, I will simply give you this information. I will not give you this information. And then you will make mistake. Because you might be thinking, you will be thinking that, yeah, this information is given. So you will use this information. But you will not use this information that it is on to also. That it is on to also. This information you will not use. And this type of many questions I can create. I can create many questions where I will give you that this combination, and I will say that this happens. Then you should remember that, yeah, okay, on to also there. In this, on to also there. So this is what I'm saying. Hopefully you understood. So just remember that in any, if I give you this information, what should come to your mind? With this deadly combo, if I give you this information, what should come to your mind? That f is 1 1 also. Okay, so finally, if I give you this deadly combo, then you should remember that f is bijection. All these points, important points. Okay. So actually, why I'm telling you all these things, that you should remember this deadly combo. You should keep this in mind, that in this deadly combo, if this happens, then this will also happen. Why I'm telling you this? Because once upon a time, I was solving a standard question. I think that was from Berkeley University or Stanford University. Okay, I was solving. It was me. I was solving a question, and I was not getting the answer. The answer that they had given. Okay, it's almost 3 or 4 years ago. Okay, so when I was in ISC, at that time, I was solving this question, a standard question I was solving. I was not getting the answer that they had given. Means my answer was different from their answer. The reason is simple, because they had given this information, this deadly combo was given, and also this line was given. But I was not using that this function is all to also. This function is on to also. So after that, I got to know, okay, this happens. Okay, then it was like, after that, I can never forget it. This is what I'm telling you. Okay, because I was stuck on that question. And once I got to know that with this deadly combo this happens, then I could never forget. Okay, that so that the same thing. I'm just suggesting you. Of course, if you make a mistake in some question in the Go classes test series, if you do some question and you make a mistake, then you will never make that mistake again. Do you agree with me? In the Go classes test series, of course, I will give you. Of course, now you already know that in the test series, in the weekly quizzes, there will be multiple questions on this combination. Okay. So the point is, if you make mistake, then don't worry about it, because once you make the mistake, then you will never forget it. Okay, then you will never repeat that mistake again. So that is the benefit. Okay, but anyway, I think now also you will not make the mistake, because now automatically it will come to your mind. So this question we have done, a very interesting question. The complete analysis of this question I've told you. I've told you when this happens, finite, infinite, all the variations, everything we have seen. This complete analysis we have done.